Sup, investors? Wait, that's not right. Give me 1 second. Yeah, that's more like it. Hello, esteemed Flingbore investors. It is I, CEO Flingbore, risen back from the dead to present another one of my amazing marketing ideas. If you've been following Flingbore Incorporated for a while, you know we have some great ideas. Now, we have a fully constructed email with all the information you would ever need to properly fire a lazy employee. And today, it's no different. What do you know about the youth? Yes, those dirty Gen Alpha, Gen Z kids who seem to control the world and control their parents' wealth. A lot of CEOs don't know much about the youth, which is exactly the problem. There exists a large divide today between the youth and the corporations trying to reach them. Many young people feel as if there's some kind of barrier separating them from the handsome, wealthy, rich CEOs that we are, who are trying to convince them to buy our product. Top business analysts have long since debated the problem of connecting to the youth, be it through extremely funny social media campaigns, through creative and wacky ads, or through those fake social media beefs that Wendy still seems to be trying to do, even though nobody has found those funny for years. I feel as if we have been missing that critical youth connection component, or YCC for business speak. That's why I send my army of unpaid interns on a mission to find the most viral, the most intriguing, the most youthful trends of today. And what they found shocked me. Vocaloids. Yes, if you spend a lot of time scrolling reels, as I have, you know how big the Vocaloid craze has become. These little talking, singing things, I can't say that, 2D animated avatars singing all sorts of crazy songs have captured the mind and the attention of many a young person. I mean, look at how many views this video has. Holy shit. I want those kinds of views. I think it's high time we here at Flingbore Incorporated finally invested into this new field of technology. And what better way to do so than turning my handsome, sultry, rich CEO voice into a Vocaloid. Yeah, I turned myself into a Vocaloid, as the title would suggest. Let's get to it. Before we even begin developing our proprietary Vocaloid technology, we must first understand what a Vocaloid even is, and how speech can even be produced by a machine, which is a history that's actually more interesting than you might think. Text-to-speech, also known as speech synthesis, is the artificial production of a human-sounding voice. Whenever you hear a donation in a Twitch chat, whenever you hear a robot talking to you over some Minecraft parkour reading out a Reddit story,
am I the a-hole for telling my husband I'm done caring for his daughter?
all of that is developed through a process called speech synthesis. And that's pretty much what we'll be developing today. The idea of synthetic speech actually dates long before the first computer was even created, even before electricity was even invented. Our story begins all the way back in 1245 CE. This is Gautier de Main, who will go on to write Image du Monde, or Image of the World for my non-French speakers. In one of the stories contained in this book, the Roman poet Virgil is said to have created his own oracular head that answered questions about the world, as you commonly did back in the time. This story was later recycled in the 1319 book Reynard the Fox, where this head was actually retconned to be made of brass. Of course, no such talking head was actually invented by Virgil, but this story captivated people so much that brass heads became kind of a staple of writing back then. This drive was fueled a lot by the Arabic work on mathematics and astronomy, and as more and more people discovered the wonders of science, more and more writers decided to write about their own talking heads. Alright, these names are about to get really hard. From Robert Groteste, Albertus Magnus, and most famously Robert Bacon, who is probably a distant ancestor of Kevin Bacon, I presume. Everyone was getting into the talking heads game. Despite this enthusiasm for talking heads, it won't be until 1961 when John Larry Kelly Jr. and Louis Gerstmann used their IBM 704 to produce this. And if that doesn't freak you out, I don't know what will. Side note, if you watch 2001: A Space Odyssey by Stanley Kubrick, you'll recognize this song. Kubrick used the same song in that to represent the robot dying because it's the first song that was ever taught to a computer. So you may be wondering, Flingbor, this history lesson's amazing, and you're a great commentator, but where do Vocaloids fit into this? To discover that, we must fast forward to 2003 at Yamaha. Invented for the German fair Music Mess, the first Vocaloid software is invented. The first version of the Vocaloid used analysis of human samples to create sounds, but is later swapped out for a more direct approach of literally using the vocal samples in the work. Now, with the history of the artificial voice out of the way, we can finally begin discussing the technology behind the modern day Vocaloid. The modern Vocaloid has really three parts to it. 1 is the score editor, 2, the singer library, and 3, the synthesis engine. For our video's purposes, we'll be creating very basic implementations of each, mostly because I don't have a team of like 30 people and years to do this. We'll start in the score editor. This is the basic interface which the user uses to create their Vocaloid tracks. All we need to do is receive a pitch, duration, and syllable for each note, and then we just pass that into our synthesis engine. In the synthesis engine, we'll be utilizing the singer library. Basically, our singer library contains the vocal samples used to produce the songs. These vocal samples are called phonemes. A phoneme, for those not well versed in linguistics, like myself or like 99% of the people watching this video, is the smallest unit of everyday speech. These are recognized as like single basic sounds that make up larger words. If we're using my favorite type of analogy, a chemistry analogy, to explain it, if we think of words like compounds, we can think of phonemes like the atoms making up the compounds. Phonemes are the smallest possible part, but when combined, they create words. To create a singer library, we literally have to record ourselves saying every possible English phoneme in the English language, which, surprisingly, there's only 44 of. I actually thought this number would be a lot higher, but in doing some research, nearly every word in the English language is comprised of these 44 different phonemes. A quick side note, when we get the results for this project, you'll hear that it's kind of a little weird, and that's because we're using English as opposed to Japanese. Japanese is a syllabic language, meaning that every single word is specifically broken into its syllables. In English, you get a lot of slurring between syllables, where in Japanese, everything is kind of very defined. This makes Japanese Vocaloids a lot more accurate, as using simple syllable samples is a lot easier than trying to slur together words. So here we are in my state-of-the-art sound recording studio. Maybe a little less high-tech than what Yamaha had, but nevertheless, I'm about to record the phonemes, or however you say it. Wait, I forgot to record. So stupid. Oh man, I don't know if this is gonna work very well. Okay, that one's gonna be another short one there. Don't use that one for too long. That's so stupid. I'm doing like Mongolian throat singing right now. What am I even doing? All right, that's all the consonant sounds. Now it's on to the digraphs. Just be glad you're not here in person. I'm going to be spitting all over my screen on this one. Shh. All right, there's TH. I'm going to call it unvoiced. Error. There we go. Those are the 44 phonemes. What I learned is that R's are really weird, and don't do this by yourself. Or do this by yourself. Don't let anybody else see you doing this. So, all right, back to the narration. Lastly, we create the synthesis engine. Here, we'll be taking input from our score editor and then pairing together clips from the singer library to form the completed song. We'll have to pitch up and down the phoneme as well as trim it to the desired duration. But once we do that, if we can just stitch them all together, we'll have created an entire Vocaloid track. Of course, I'm wildly oversimplifying all of this technology. This took years for Yamaha to completely develop and a huge team of people, but for my purposes, I'm going to take the easy way out and kind of make really simple versions of all of this. I chose to do this project in C# for two reasons. One, it's really easy to build desktop applications with C#, and two, I need to learn C#. Yes, the C devs can rejoice that another person has decided to learn their language. First, let's construct the score editor. I'll be using the app building framework Avalonia for the front end, which allows us to create really easy customizable windows that we can display to the user. Really, all I want to do for this front end is be able to drop in a JSON file of the song and then compile it. I was going to make a really complex digital audio workstation, kind of like Fruity Loops or something, but that's way above my pay grade. So I just drop in JSON files, which we're later going to read from. Now we go into the synthesis engine. Here we utilize the great, amazing, awesome, revolutionary principle of object-oriented programming. If you already know what object-oriented programming is, skip to this timestamp, but I'm going to explain it for my less technical savvy viewers. OOP revolves around one concept, the object. To use the classic example, we can think of an object like a car. It's not a crazy statement to say every car is a car. At least I hope not. Well, why can we say that? Why can we look at a blue sedan and a red hatchback and say, yeah, those are both pretty much cars? Well, it's because of the similar features that the two cars share. Every car, while different in certain ways, has similar characteristics that bind them together. Every car has wheels, windows, turn signals, all of that stuff that makes a car, well, a car. In programming, every object is a member of a class. Just like before, your car, probably like a Lamborghini or Ferrari if you're a Flingboard subscriber, is a member of the class car. It has its own features, but at the end of the day, you could park it in a garage and nobody'd look at you that weird. This is what's known as an instance of a class, and is common in a lot of object-oriented programming. So back to our Vocaloid. We'll use two classes to construct a song, the note and the track class. Starting with the note class, this defines a singular note. The note contains 3 instance variables, basically variables that change with each instance of the class. These instance variables are 1, the file path of the note's phoneme, 2, the duration of the note, and 3, the pitch of the note. Our note right now is mainly just a place to store data that we'll use later when we compile it in the track object. Whenever we want to create a new note object, we can instantiate a new member of the class. Great, but notes by themselves don't make a song. Beethoven didn't write music with only one note, because that would kind of suck, wouldn't it? For a composition of notes, we need to create a track class. The track class is a lot more complex, primarily because it contains all of the logic revolving around playing the actual notes. Our instance variables here are the track name, the tempo, and a list of notes. Also a list of audio file readers, but we won't have to worry about that one much for now. See how combining the note class and the track class allows us to have more functionality with OOP? OOP truly is amazing. We also want to define 3 functions for the track class. First, we need a function to add new notes to the track. If we're reading note by note from a JSON file, we can just add to that previously mentioned notes list rather than having to create a huge array and then put it into a track object. This function also has some fun logic using in-audio C# directive to crop the note and pitch it up or down. With this funny little math equation, we can pitch the notes up and down semitones. Next, and most importantly, is the play function. This function is what's called a task. In C#, or in the C languages in general, a task represents an asynchronous function. Because our app involves a GUI, we can't just freeze up the main thread whenever we want to play a song. For this, we'll need to use asynchronization, whatever the word is for that, and be able to run that while we're still running the GUI. If you want to learn more about what's called multi-threading, which is what we're defining here, watch this video. Inside of the play function, we use what's called a concatenating sample provider and string multiple notes back to back in order to start building the track. This is where I ran into a big bug, which took me way longer than it should have to fix. Let's play 2 truths and a lie. 1, I run Arch Linux. 2, this is a YouTube video. And 3, I love Windows. Yeah, the third one's the lie, obviously. Listen, if you use Windows and you're a Windows enjoyer, if those exist, cover your ears and make loud noises for the next couple minutes. Your OS is terrible. Not only does it fill up your computer with a ton of bloatware, it also just makes stuff work worse. Since the C# language is a product of Microsoft, they obviously decided to implement a bunch of stuff to make it so none of their things were cross-compatible with other operating systems, as Windows likes to do. In audio, specifically, requires some low-level Windows APIs to play audio locally on your computer. Problem is that the developers of InAudio never bothered to create a Linux alternative to their Windows-only media player. Anyways, tangent about Windows aside, we just need to add an operating system check, and then if we're running Linux, we just save it to a WAV file, which kind of sucks, but hey, Linux on top. And now, after all of this great hard work, we now have a very, and I mean very, basic bare bones Vocaloid software. Let's hear it say its first words. Yeah, After saying some basic phrases, I now want to build the Daisy Bell song we heard from the beginning. It's almost like the hello world of speech synthesis devices. Now, without further ado, I present Daisy Bell by myself? Yeah, that was... The captions really helped you there, didn't they? I don't know if I should be proud of my little robot son or disgusted by how scary he sounds. Saying that, I know I'm not a very good father. Well, that's that. Flingboard Incorporated investors, I can already see our stock shooting up from this new investment, as you can note here. When thousands of people are building things out of my voice, which in hindsight does not sound like a very good idea, we will become the mega corporation of all mega corporations. Remember, and join me next time where we build the Flingboard Incorporated Mega Tower.